All right, next up we got number 21 here. So for this one, it says how much money invested at 3.5% compounding continuously, which means I'm going to use a PERT. For 5 years will produce that much. So really here, we're actually looking for P. So we're finding out how much we want to invest. We want to end up with 450, so that's A. And then we have e to the 0.035 times 5. And then we're going to divide this by e to the 0.035 times 5 on both sides. And just type that into your calculator. And that should give you your answer for P. All right, next up here, we want to write this in the form ab to the x. Now, I always know that a is the y-intercept in this form, so I know that this is a. And so I'm going to say y equals -4 times b to the x, and then I'll use the other point as my x comma y and plug in to find out what b is. That's -20.25 equals -4 times b to the power of 4. And so next up, I'm going to divide both sides by -4. So this is calculator question, so we'll do that. 20.25 divided by 4. And you get 5.0625 equals b to the 4th. And then I like to raise this to the 1/4 power, really meaning the same thing as the 4th root here. Now in the calculator, you need to make sure you do that to the parentheses 1/4 power. And if I do that, it tells me that b equals 1.5 or 3/2. So I'll just finish up by writing it in this form. So I'm going to say y equals -4 times 3/2 to the x power. All right, next up here, we are going to write this one in this other form, a times e to the rx. However, I still know that a is 5 based on the y-intercept. So I'm going to say y equals 5 times e to the rx, and I have to solve for r here, so I'm going to use this other point as an x comma y, just like I did last time. So 4 equals 5 times e to the power of 2x. Oh, actually, I messed that up. It would be r times 2. So my variable is in the exponent, so I need to use a log here, but first I'm going to move this 5 over, and then I can switch it to log form. So log base e, or ln, of 4/5 equals 2r. And you can just divide both sides by 2 to find r. All right, next up here, we're going to use Newton's law of cooling. Oh, I cut that off. Hold on. All right, so let's see. It says kettle is brought to boil in a room with a temperature of 24 degrees. After 13 minutes, it's decreased from 100 to 80. Find the temperature after another 10 minutes. Okay, so I see here that the temperature of the room is 24, so that's the temperature of the surroundings. So I'm going to say T of T equals 24 plus, and then I know this is going to be a -24 in there since that one shows up twice. And then the temperature of the object is 100 degrees because I brought it to a boil. And then we have e to the -kt, and I don't know what k is yet. That's kind of my first goal here, is to figure that out. So I'm going to plug in the other point here. It's 13,80, so I'm going to put 80 here. And then I'm going to do this subtraction. It's going to be 76 e to the -k times 13. And so I'm going to isolate e and switch it to log form. So I'm going to subtract the 24. And that gives me 56 equals 76 e to the -13k. Then I'll just divide this by 76. I'm going to go ahead and leave that as a fraction. And now I can switch it into log form, so it's base e, so ln of 56 over 76 equals -13k. And I'll just divide that by -13 on both sides. And that gives me my k value. So now that I have my k value, I'm going to find the temperature after. Actually, I'm going to build my function here. So my function is T of T equals 24 plus 76 times e to the negative. Actually, it's going to be, the negative is going to cancel out with the negative in the formula, this negative down here. So that'll actually be positive ln 56 over 76 all over 13 times t. And so now after another 10 minutes, that's after the 13 minutes, so it's really asking for t of 23. I would just plug in a 23 for t. So my exponent will say ln 56 over 76 over 13 times 23. If you type that in, you should get the right answer. All right, next up here, it says that, let's see, another Newton's law of cooling. They tell us K here, which is nice. And then we have our temperature of the surroundings is 60. And then 74 degrees is the temperature now. And so I need to find T. Okay, so let's build this. And 98.6 is the temperature originally of the body when it died. So I know here we can set it up as T of T equals, let's see, temperature of the surroundings is 60, and then 98.6 minus 60 to the times E to the negative 0.1947 T. And so now I know that we're plugging in, and we're plugging in 74, figure out how long ago that was. So I'm just going to subtract the 60 over. So I get 14 equals, and this will be 38.6 e to the negative 0.1947 t. And then we'll go ahead and divide that by 38.6, both sides. Okay. And then we have E there as our base isolated, so I'm going to switch it to ln of 14 over 38.6 equals negative 0.1947 t, and then divide that by negative 0.1947 to both sides, and that should give us our answer. So I'm going to go ahead and type this one in the calculator. ln of 14 divided by 38.6, close that parentheses, and divide it by negative 0.1947. And you get T at about 5.2 hours. Make sure you do that too. All right, last one here, the domain of the function. If it's a log, we have to do the inside of it greater than 0. So I would go ahead and factor this. It's non-linear, so we're going to have to use test points here. So I have negative 7, I have positive 7 with open dots. And instead of test points, you can always draw a picture of the graph. So a positive parabola would be looking like this. And so I would say that's negative infinity to negative 7, parentheses, 7 to infinity.